summarize, what we have understood so far in projectile motion is, that is, first we break the velocity. This velocity u along the two axes, one is along the x-axis, the other is along the y-axis, because our intention is primarily to break this motion in two dimensions as individual motions along the x-axis and along the y-axis. Once we know it is motion in one dimension along the x-axis or along the y-axis, then simply we can use the equations of kinematics and we can make use of sign convention to get to the various formula or get to the various results. So generally, most of the time, first we shall be breaking this velocity in two components along the x-axis and along the y-axis. Apart from this, we have to remember that is acceleration on the x-axis is equal to 0 because there is no force along the x-axis. The only force which is being applied on the body is only by earth, that is gravitational pull, and it is purely vertically downwards in this direction. As a result, the component of this vertical force along the x-axis is going to be equal to 0. That's why F is equal to ma. When the force along the x-axis is equal to 0, then the acceleration on the x-axis is equal to 0. It means the velocity along the x-axis will remain as u cos theta only. Also, along the y-axis, acceleration is acceleration due to gravity, and this is in the downward direction. We shall also remember that is, if we are sticking to this sign conventions, the vectors in the upward direction, suppose we are taking it as positive, then in the downward direction we have to take it as negative. Apart from this, the velocity component along the y-axis, at the highest point this is going to be equal to 0, because right now this is the highest point. It means the body doesn't have any tendency to move further up. So that's why the velocity component at the highest point along the y-axis, that is going to be equal to 0. When we are using the equation of kinematics along y-axis, we shall be understanding what is the displacement along y-axis. We shall purely be bothered about, that is, how the displacement along the y-axis has taken place. We shall not now be mixing it up with what is happening along the x-axis. When we say displacement on the y-axis, we are bothered about how much the body has gone up or below the initial level of projection. And when we say what is the displacement on the x-axis, so we are interested how much the body has gone in the forward direction or in the backward direction. When we are talking the forward or backward direction, then we shall not be mixing up whether the body has gone up or down. When we are talking about what is the displacement on the y-axis, then we shall not be bothered about how much body has moved in the forward direction or backward direction. So once this is clear, then we can directly use the equation of kinematics to get to the various results.